Hey guys, happy Thursday. I want to continue today off of what I started yesterday with just a really brief review. We'll start here with diatomic molecules. If you'll remember, di prefix means two. Think back to your mono, di, tri, tetra, and what types of bonding did those go with? Those went with covalent, because co means for two to share. Diatomic. So anytime hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine are by themselves in an equation, they always have a 2. That 2 does not carry over here. That 2 came because oxygen is a 2 and it crossed over there. Your reactants is what reacts together to form, meaning yields, a compound. So this is the way that you would write the chemical equation. And this is an example of a synthesis because you have two things, two elements, come together to form one thing, which is a compound. All right, moving on from there. I'm going to put this up, and I would like for you to pause the video and copy this down so that as I go through it, you'll be a little bit easier able to follow it along. So take a moment and copy this down. Okay, so I assume now you have copied this down. Now I'm going to go through and work this. These equations are already written out for you. We're going to start real simple and simply count, which is something that we were working on before we left school, was counting the atoms. So that is what you're going to continue with here when you balance. When you balance something, you want to make them equal. So your yield sign is like the equality. It's the separation of the reactants and the products. For this second one, you have the reactants, products, what it produces. Separate, reactants, produces over here. So you want this side and this side to equal. Think about one of those old scales that has the fulcrum point in the middle and the pans on either side, and you want to make them equal. That's what you have to do in chemistry. So we're going to start out and you count. So remember, this is your divider line. If it helps for you to physically draw a line to separate, that's fine. Count. 1 calcium, then come over to this side and you have 1 calcium. Come back over, you have 1 oxygen. Over here, you have 2 oxygens. 2 bromines, 2 bromines. You have counted. So now you want to make the numbers equal. If you have oxygen here, you want the same amount on both sides to make them equal. So here you have 1 calcium and 1 calcium. So your calciums are balanced. You have 1 oxygen and 2 oxygens. Not balanced. 2 bromines, 2 bromines. Balanced. Now you're going to add what we call a coefficient. You have heard that word before, but I'll write it for you. Coefficient. C-O-E-F-F-I-C-I-E-N-T. Those are the big numbers that you're putting in front of the formula. So calciums are balanced, bromines are balanced. I have 2 oxygens here, I have 1 oxygen here. As we've been talking, you cannot split up a compound. So it's like a family. You can't split up the family. So you're going to have to add a coefficient in front of the formula. Use that distributive property we've been talking about. So now you have 2 calciums. Now you have 2 oxygens. So now my oxygens are balanced, but now my calciums aren't balanced because I have 2 over here and 1 over here. So I have to add a 2 here to make that 2 calciums and 2 calciums. So now my calciums are balanced and my oxygens are balanced. Those are good. Count your bromines. 2 bromines, 2 times 2 now gives me 4 bromines. Go back over here. It's a lot of seesaw, back and forth. Go back over here, and you're going to add a 2 here. 2 times 2 is 4. Now I am balanced. So the coefficients you have added is 2, 2, 2, and nothing. This is now a balanced chemical equation. It's counting and it's making it equal. Okay? If you need to pause and go back and watch that example again, feel free. But I'm going to move on and work number 2 with you. Number 2 is a little more complicated. It's a lot more letters, but you probably can look at it and actually name them. And what I want to do when we finish this, I want to go back over and classify it, single, double, decomposition, what we did yesterday, as well as practice naming them again. So, count. 2 coppers. Oh, you might want that divider line to show the back and forth. 2 coppers, 1 copper. Okay, well, you'll have to fix the copper. 3 sulfates. If at all possible, keep the polyatomics together. It's easier than breaking that down into 3 sulfurs and 12 oxygens. If you want to do it that way, that's fine, but I'd rather go the easy route. Sulfate. You have 3 sulfates, 1 nickel, 1 chlorine, 3 chlorines, 2 nickels, 1 sulfate. Can't break up polyatomics, families together. Now we have counted. At any point, if you want to go back and see it again, rewind this. Now that I've counted, I need to start figuring out what to do with my coefficients. So the first one I like to start with are polyatomics. Always start balancing with your polyatomics because they're usually the most difficult and they take up the most space in the equation. So I have 3 sulfates, 1 sulfate. So now I have to put a 3 in front of the formula, the compound. Remember, I can't break it up. You can't put a 3 right here. And coefficients are big numbers in front. They're not little, they're not low, they're not high, superscripts, subscripts, big numbers in front. So now distribute. Now I have 3 sulfates and I have 3 sulfates. That in turn changes my nickel to 6. 3 times 2, distribute, is 6. Come back over here, I have 1 nickel. Put a 6 there. Now I have 6 nickels. That changes my chlorine to 6. Distribute. That 6 over here, I put a 2 right there. 2 times 3 is 6. So now my chlorines are balanced. That in turn changes my copper to 2. Come over here, already have 2. Now you're done. It's balanced. But let's go through and count just to make sure. I'm going to use a different color. 2 coppers. I come over here. 2 coppers. 3 sulfates. 3 sulfates. 6 nickels. Distribute, multiply. 6 nickels. 6 chlorines. 2 times 3 gives you 6 chlorines. It's balanced. If you have a problem, some of the ones that I've posted on Google Classroom or those of you that have come to pick up the paper, if you can't get it to balance, then there's a problem. It will always balance out. Either you're not putting the correct coefficients in, or maybe you wrote the formula wrong if you're writing it out from scratch. But it will always, always balance. If it balances, you know you did it right. Last one. 110, 2 hydroxides, 3 ammoniums, 1 phosphorus. It's not phosphate, phosphorus. 3 tens, 2 phosphorus, 1 ammonium, 1 hydroxide. Very important, you're still familiar with your polyatomics. And I did post another picture of those online in case you don't have the notes of your polyatomics. Now that we've counted, go through and balance. Start with your polyatomics. I have 2 polyatomics of hydroxide. I have 1 hydroxide. I have 3 ammoniums. I have 1 ammonium. So now you've got to figure out how to balance this. So you'll put a 3 here. That gives you 3 ammoniums, 3 hydroxides. But I have 2 here. So how do you make a 2 and a 3 equal? Bump it up to 6. So I'll have to put a 3 here, which then goes back and changes that to a 6. Getting numbers to be high. So now I have 6 hydroxides distribute 6 hydroxides. 3 tens, 3 tens. Looks promising. 3 ammoniums, 6 ammoniums. So you got to bump that up to 6. You can never reduce the number. It always has to go up. So if you have 6 ammoniums here, add a 2 here. 2 times 3 is 6. That in turn changes your phosphorus to 2. I have 2. It's just a stapler. I'm balanced. But always go back and double check everything. I'll use a different color for counting again. I have 3 tens, 3 tens. 3 times 2 is 6 hydroxides. 6 hydroxides. 2 times 3 gives you 6 ammoniums. 6 ammoniums. Can't split that up, remember. 2 times 1 is now 2 phosphorus. 2 phosphorus. We're balanced. So this is how you basic balance. And in going back, let's label this. I have a compound, an element, a compound, and an element. So that is the single, displacement, or replacement. Compound, 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 compound. That's a double. And compound, 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 compound. That is a double as well. Okay? Now, I want you to pause the video, take a minute or 5, and name each one of these compounds. Scribble it down on a piece of paper, and then I will tell you these names for you to self-check yourself to assess, are you still remembering how to name these compounds? So pause it for a second at this screen, and I will also post the picture on the classroom site as well so you can see that if you're not able to see the screen very well because there's a lot going on. So pause it now. Now we're going to name these. Calcium oxide, bromine, calcium bromide, oxygen. Copper 3 sulfate. Copper is a transition, uncross. Copper 3 sulfate. Nickel 1 chloride. Nickel's a transition. Copper 3 chloride. Nickel 1 sulfate. Tin 2 hydroxide, transition. Ammonium phosphide, IDE, because it's the element, not a transition, binary compound. 10,2-phosphide ammonium hydroxide. So, how'd you do? Okay? I'm going to put some more examples up here. Here are 3 more. Pause, copy this down. Then we're going to work through this together, but I want you to practice these on your own first. So pause the video, copy this down. And remember, at any point, you can take pictures of your work, you can scan it, and then you can either share it with me on Google, you can email it to me, you can text it to me. I have a Google Voice number. I'll write that down in case you forgot. It's 362-0015, and I will be happy to check over any work that you have. Need to do some form of assessment to make sure that we're going in the right direction here. So you need to send this work to me in some format. Email, share it, text it, and I will also be posting some quizzes for you to practice some assessments online. So pause it, copy this down. Now I'm going to write out the equations, and you're balancing, but you're going to have to write these from scratch. We have beryllium and chlorine. So if you're mixing beryllium, which is Be, plus chlorine, diatomic molecule, yields BeCl2. That 2 did not go here. That 2 is because beryllium is a +2. So how did you do with that? And what type of equation is this? Synthesis. Is it balanced? 1 beryllium, 1 beryllium, 2 berylliums, 2 chlorine, chlorine, balanced. Okay? Take a moment, write this out. Sodium, chlorine, plus, did you remember your diatomic? Fluorine, plus. Now, these are going to swap partners. Remember, positive, negative, and that's a negative, so now sodium gets with fluorine. They swap prom dates. Remember, don't carry those 2's over. Those are simply because it's a diatomic. +1, -1, NaC, Na F plus Cl diatomic. This is how you write it out. Now, pause this, balance it. Going to go through now and count. 1 sodium, 1 sodium, 1 chlorine, 2 chlorines, 2 fluorines, 1 fluorine. Start with your chlorines. 2, that now changes sodium to 2, sodium to 2, 2 chlorines, 2 chlorines. I have F, so I have to put that there. That gives me 2 sodiums and 2 fluorines. Fluorines are balanced. Sodiums are balanced. Chlorines, so double check. You think you're done? Always double check. 2 sodiums, 2 sodiums, 2 chlorines, 2 chlorines, 2 fluorines, distribute 2 fluorines, balanced. And what type of equation is this? Single displacement. Last example, pause, work this out on your own and write it out. Iron 2 sulfide and cesium iodide yields, and how is this going to swap elements and partners? Here we go. FeS Why, you say? Because iron is a 2 and sulfur is a 2. They're going to cross and cancel. Plus CSI. Plus 1 minus 1. Yields. Swapping partners. Iron will now become with iodine because your positives and negatives have to come together. So remember, your iron is a 2 and your sulfur is a 2. So these numbers transfer, not low numbers. So you are going to have Fe(I)2 and Cs(2)S. Because iron is a plus 2, iodine minus 1, plus 1 minus 2. So, any questions so far? Always shoot me a comment. You can include the time point, and I'll be happy to reply, either private message or I can always comment. But any questions you have in this video, comment, timestamp it so I'll know what to go back to help you. Now you're going to balance. 1 iron, 1 sulfur, 1 cesium, 2 cesiums, 1 iodine, 2 iodines. So I have to change my iodine and my cesium. Put a 2 here. Now I have 2 cesiums. That in turn changes my iodines. That's it. Go back and check it. 1 iron, 1 sulfur, 2 cesiums, 2 iodines, 2 iodines. Good. And this is a double because you have a compound. So this is where we're going to stop for today. I've gone over 6 examples. I know this was a lengthy video, but this can be a little tricky to understand. I will take a picture of this and post this on the site as well. Please remember to continue doing the work that I've posted. Share the answers with me so that we can get you some documentations of participation and grades. I'll be happy to help and assist. Email, call, text 362-0015. Let me know who you are because I don't have your personal numbers, and I'll be happy to help with anything that I can. For now, we're still able to come out here to school, so I can still send home paper copies of work if you would prefer that, because maybe you can't download things at home, you don't have a computer, so you're having to view it all on your phone. If you can at least view the videos, then you can do the work on paper, and then you can always take pictures and scan it and text it to me. That's fine. We're all in this together. This is new for all of us. I really appreciate those of you that have been working mid-hard online and uploading things and calling me and texting me and commenting and messaging. I will continue to post a daily check-in every day. You need to be logging into Google Classroom to do something. I might not have a video every day, but you will have work that you can pace yourself and work throughout the week. So thank you all very much. I'm happy to help. I'm available by phone and computer at home. So good luck, stay safe. Let me know if you need anything, whether it's school or personal. I'll do what I can to help you.